Hello everybody, welcome to another video in which I try to explain physics as simply as possible but not simpler. Here I continue the topic of acceleration, accelerated motion. So if you haven't seen my previous videos on this topic, I encourage you to check them. They are available here and also in the description of this video. Okay, so now let's discuss the graphs. So let's draw the graph speed in meters over second versus time in seconds, and let's suppose that for example, a car has acceleration 2 meters per second squared. Okay, I remind you that acceleration is change in speed divided by time. So what does it mean? It means that, for example, within 1 second, the speed changes by 2 meters per second. And that's right, because 2 over 1 is 2. Okay, so if in the beginning speed is 0, so that the car doesn't move, then after 1 second its speed is 2 meters per second, so 2 meters. Okay, then in another second it also increases speed by another 2 meters per second. So after 2 seconds, the speed will be 4 meters per second. Here. After another second, again again 2 meters. So in total, it will be 6 meters per second. This is, of course, I'm discussing still the case of uniformly accelerated motion, which means that acceleration is constant. So in every second, the car increases its speed by the same amount. So also in fractions of seconds, so I can connect the points, and this is straight line, and it keeps going if the car keeps moving in the same way. Okay, so here is the graph speed versus time. And now how to calculate the distance in uniformly accelerated motion. Okay, I remind you that when we discuss the uniform motion, so motion with constant speed, we also were drawing the graph. So in that case, speed versus time was even simpler, because when speed is constant, well, speed was constant. Okay, so speed didn't change. So if we wanted to calculate distance, I showed you that distance in some time can be calculated if you draw such a vertical line, and here you have a rectangle, and it turns out that the area of this rectangle is distance, because it's speed, here is speed, multiplied by time. Okay, in this case, in uniformly accelerated motion, this formula is no longer valid, but what is valid, what is still correct, is that the distance is the area of the figure below the plot of the function. So in this case, that's the area of this triangle. So the area of any triangle is the side times the height divided by 2. And in this case, here you have right angle, so it will be just this side times this side. Okay, and look, this side is of course time, and this side is change in speed, because it's final speed 6 minus initial speed 0. It's indeed the change in speed. So the distance is area of this triangle. So distance is change in speed multiplied by time divided by 2. And this is for the uniformly accelerated motion, and in a simple case when initial speed is 0. Okay, in next video I will show you an example of a simple problem where we calculate the distance covered by Ferrari car. So I invite you to stay tuned.